Yeah, what's that? They're called
All right, the last problem says we have a function that looks like this. All right, so here's our function. Remember, this is no calculator. This is a no calculator problem, so you are on your own. We want to know where this thing where it equals 18. Right? So we're solving the equation that says literally 2 to the 2x minus 3 times 2 to the x minus 18 equals 0. I'm solving this equation. That's a double exponent, kids. What do I do when I have a power to a power? Multiply them. Okay? All right. Now, this equation, believe it or not, is going to be done with the quadratic formula or by factoring because it is in quadratic form. This is 2 to the x squared minus
interruption. Will all choir members please head to the rack to prepare for math? Will all choir members please head to the rack to prepare for math? Thank you.
So look at that. Let that digest a minute. Think of 2 to the x. Think of this as being like something like a. Doesn't this equation say I have a squared minus 3a's minus 18? Isn't that what it says? Now I know it's not an a, but it's that thing is the same. If it said this, if this were your equation, you would not have a problem solving that. What would you do? You would say a minus 6, a plus 3. Right? And so a equals 6 or a equals 3. Negative 3. Now, what did I let a stand for? 2 to the x. So 2 to the x equals 6 or 2 to the x equals negative 3? Well, this one's not possible because you can't raise 2 to a power and get a negative number. Agreed? Okay. This one, if they had rigged it more carefully, they would have made this like an 8, and then you would know x equals 3. I don't have a calculator, but to solve for x, which is what I need to do, I log both sides. So when I log both sides, I'm going to get x log 2 equals log 6. So x equals log 6 divided by log 2. You could also, I don't think there's anything wrong with that, but you could also, instead of log base 10 both sides, which is what I did, could I have ln to both sides? Yep. Could I have log base 2 both sides? Sure, you don't have a calculator, so it doesn't really matter. What would happen if I log base 2 both sides? X equals the log base 2 of 6. So I think you could answer this way, that way, with ln's, but the point is, the equation was in quadratic form. You see that now? Kind of tricky there. Kind of tricky. All right, I will open up those answers. But I'm not going to do it right now. We're going to move on. We don't have much time, so we're going to move on to our multiple choice questions. So we're on test 2, and we're doing multiple choice. I have no idea where to put my answers. So, we're gonna go without answers. Here we go. All right, number 1. All right, consider the function what is the x-coordinate of the intersection? So this is kind of like the one I gave the boys when they were announcing volleyball. We want 4 to the x to equal 16 to the x. Is that plus 2? Plus 2? Does that make sense to everybody? We want to know where they intersect, so that's where they're equal. What are you gonna do? You're either gonna change everything into 2's, or you could just change the 16 into 4 squared. So 4 to the x equals 4 squared. The x plus 2. Now, what's gonna happen right here? Double exponent.
X equals 2x plus 4.
That's gonna be 4 to the 2x plus 4. And then we can just set them equal to each other. So it looks like x is -4 if I did my arithmetic correctly. Does that seem okay? What input value yields an output value of 4 in question number 2? So, in other words, the log base 2 of what will give me 4? What do we do? Log roll it. So 2 to the 4th equals x. The answer is 16. Boy, we could do these all day. Number 3. The function, what are all the values of theta where the function equals -1? So 2 sine theta has to equal -1. Do you agree with that? All right, well, we've done lots like this, I feel like. Shall we divide by 2? Where's the sign negative? It's negative down here. What angle has a sine of 1/2? Pi over 6. So down here it would be 7 pi over 6 and 11 pi over 6. Now let me make sure that there's nothing tricky. No, it says 0 to 2 pi. So there we go, right? Which of these equals the log base 3 of x to the 5th? What happens in logarithm land when you have a power on the thing you're logging? It goes to the front. So 5 log base 3 of x, is that an option? Yep, that is your answer. Man, we are flying. Which of the following statements is true about the exponential function given by this? Now guys, this is no calculator. So if you think you're just gonna graph it, you're wrong, unless you graph it by hand, which you could absolutely do. I'm going to do that. But we need to remember a couple of things. What in general does an exponential look like? Can you airdrop for me? Yes. Yes, that's what it looks like. So the general exponential looks like this. What happens when you multiply it by a negative? It turns it upside down. So now it's going to look like this. So this is my picture right here. I need to figure out always increasing, always decreasing. Well, let's do that part first. What's this guy doing? Always decreasing. Okay, so it's either C or D. Because it's concave up, or not because, but and it's concave up, or and it's concave down. Concave down, the answer is wow. Wow, good deal. Okay, we'll do a couple more, maybe one more, and then you guys can take off with each other. Here we go, number 6. In the xy plane, the graph of a rational function has a hole at 2. Input values of f sufficiently close to 2 correspond to output values close to 6. Which of the following could define the function? Now, first of all, if there's a hole at 2, what has to happen in the equation? X minus 2 has to cancel, so that rules out C and D. C and D are done. Can't be C and D. So it could be A. If we cancel out the X minus 2's, this is what we would have left, right? If we plug 2 into this, which is legal, to plug 2 into this, what do we get? We plug 2 in. We get -3. All right, let's look at the second one. What do we get on the second one? Cancel out the 2's, or X minus 2's. Now, plug 2 into this one. What do we get? 6, and that's what we're supposed to get. Because the problem says, in kind of a fancy way, if you plug in 2, you get 6. All right? Okay. Let's do the next one together. It might be, I don't know, it's a little bit different. I don't remember having stuff like this before. So let's see if we can figure it out. But let me give you a few minutes with your partners to figure that one out, and then we'll talk about that one because it's a little bit tricky. So go ahead and talk about as many as you can, starting with number 7, and then we'll come back and make sure we do 7 together, and then whatever else we need to do together. No calculator. Remember, no calculator.
You just circle C. Look at that. Decrease by 4%. C. Patrick, for 18 you get. Oh. Right now, so you should find 7 probably. I just work ahead, you know, that's what I do. It's quicker than some people. That doesn't make you super selfish, but. Sure. Yo, will you guys get for owned it. That we did. That's in that case. It's like, hold on. That's pretty quick. I've trained my entire life just there. I really have. Now you want to come at me like that? That's right. If it was bad, it would be me.
Hey guys, do your multiple choice. Do them all. Keep going.
Oh, okay.
Keep going.
Yeah. We'll do what she said.
It's signed for C. And then
Thank you. Are the others coming, or they inquire, or?
I think some of them are required.
What do you get for non?
Well, it's
I got caterpillar. Yeah, I got caterpillar.
That's what I got to do. This is divided by 2.
Sorry, I just forgot everything. Okay, here we go.
Is quadratic
Benjamin
because
David.
the 7 differences.
Don't worry, I'm doing the problem.
I think the next time I got D. I think because it has to be quadratic, it's not like we've narrowed that down. And the average is on constants, right?
I think it's 40 yards. I just wrote.
Yeah.
It has an hour.
Yeah.
It's 40.
I definitely know that. Everything changed over constant. It doesn't look like it.
Guys? Oh, I saw G of T equals 7 and I was like, that's too down. So wait, is it 8 to the 7? Oh, wait.
I know that you're not there yet, but we're running out of time, and there's a few of these we need to talk about. Number 14, everybody look with me at number 14. This is something we did, it was kind of snuck into one of the units, and this is the first time it's appeared in practice, but we need to remember how to do this. So the binomial theorem can be used to expand the polynomial function, x minus 3 to the 5th. Does anybody remember how we handle this? Pascal's triangle. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Now I'm just kind of rolling through that. Does everybody remember how that works? And why did I go down to the 5th row? Because I'm going to the 5th power. Now, I know that if I expanded this out, there would be 1, 2, 3, 4, 5, 6 terms, and every single one of them would have an x in it. The first one would have an x to the 5th, and then x to the 4th, x cubed, x squared, x, and x to the 0. Those are the x's. I am particularly interested in this one right here. Agreed? So the coefficient is going to be 10, because that's the coefficient that lines up with the term that I want. I know I'm gonna have my x cubed, but I'm also gonna have a negative 3, the other half of the problem, and it will be to what power? Second, because these two will always add up to that. So what is the coefficient? 10 times -3 squared. They don't actually work it out, they just leave it that way, that's what it is. Is that okay with everybody? Remember that? Okay, let's back up. And did anybody come up with an answer to 7?
7, yeah. Well,
That one's a little bit different than normal stuff we do. What'd you say?
I had it.
B?
I got
yeah, I also got
B?
I got C.
Okay, I got B. Why did we get B? Bryce, explain your answer.
Because at the beginning it was constantly flowing and then it slowly began to, and then as it hit the middle, it began to fill up faster.
Exactly. Stop right there, Bryce. You are right on target. If you look at the curve, the actual graph, in the middle of the graph, it has the steepest slope, which means the height of the water is rising the fastest. That's going to happen when you have a narrower vessel. Would you agree? Nice work, Bryce. Awesome. Awesome, awesome. Okay, let's run through some answers. Did anybody get 8 done? C. Perfect. We can talk about ones we need to. How about 9? C. Good. How about 10? Did you get that far? A. A. Did we get 11?
I got A as well.
A again. How about 12? D. D. Now, how do we know, what is our strategy for letter D? What are you gonna do? Find the rate of change. So you're gonna look at those Y values, or the G of X values, and you're gonna notice, well, the first one's 1, and then it's 3, and then it's 5, and then it's 7. It is not linear because those are not all the same. If you do the second differences, you notice that they're all 2. And if you have the constant second differences, it's quadratic. So the answer is, because the successive second differences are constant. We good? This is a lot to ask. Did you get to 13?
Yeah. I tried it.
Tried it?
Yes.
Shall we do it together? All right, we'll do 13 together, and we already did 14, so you can start with 15. All right, let's do 13 together. We have f of t equals e to the t, and g of t is 7 ln t. 7 ln t. And we're going to build the composition f of g. So what does that mean? If we're building the composition, it means we take G and plug it into F. So we will have E to the 7 ln t power. Would you agree with that? Now we gotta clean it up. Talked about this already. What does a number out in front of the logarithm, like that 7 right there, what does that mean? That is an exponent. So this is e to the ln t to the 7th power. What happens when you raise an e to an ln power? Those cancel. When we talk about this in my CP class, if you have an e and an ln touching each other, they're going to cancel every time. No matter what the problem looks like. If they're touching directly, they're gone. So what's the answer to the problem? T to the 7th. And that is B. We already did 14. Your homework is to finish. How many multiple choice are there? Let's finish the no calculator part of the multiple choice. Okay? So finish the no calculator multiple choice for homework. Got it? Okay. Yeah.